Okay, so we have discussed that how you should fix the variables, okay, like, or how you should determine the number of states. Okay, now let's say how do you make the recurrence relation. So let's say you have fixed the number of states. You have fixed two state, like it will be 2 DTP. Okay, so think that, let's say, the if the two states are A and B, okay, what this state will depend on. So think again in this manner, that if I have the answer of, let's say, A minus 1 and B, and let's say if I have the answer for A minus 2 and B, can I calculate the answer for AB, okay, for this state. The golden rule for thinking a DP solution, always remember, is that thinking in this manner, always remember this: if I have the answer for this state and this state, or let's say certain number of states, let's say xy, and state p comma q, can I calculate the answer for my current state. Okay, so let's say your current state is A and B. Okay, so always think that if I have the answer for this state or and this state, can I calculate my current state. Okay, so your entire goal is to find out the states, so that if you have the answer for those states, you can calculate the value of your current state. Okay, so then you can say that A and B will depend on x and y and p and q state. So from, so whenever I have, let's say, A and B, let's say I have a function with parameter A and B, I will call function xy and function pq within the function A and B recursively, so that I get the answer for these two states, and I am able to calculate the answer for my current state, which is AB. Okay, this is the intuition. Clear, Tarun, Nitesh?
Yes.
तरुण?
Yes.
तो
Yes.
बेसिकली ऐसे सोचना है कि मेरे पास कौन कौन सा स्टेट का आंसर होने पर मैं अपना करंट स्टेट का आंसर कैलकुलेट कर पाऊंगा. सिंपल थिंग, फिबोनाची की एग्जांपल लेते हैं. सिंपल थिंग, I will think in like this way, that if I have the answer for x minus 1 and if I have the answer for x minus 2, I will be able to calculate the answer for x. ठीक है. Knapsack में what we do it like this manner, that if we know the value of a minus 1, b minus weight, and if we know the value of a minus 1 and b, we will be able to calculate the value of a and b. ठीक है, तो ऑलवेज ऐसे सोचना है कि मेरे पास कौन कौन सा स्टेट का आंसर होना चाहिए, ताकि मैं अपना करंट स्टेट का आंसर कैलकुलेट कर पाऊंगा. ये, like, when you understand this, you automatically get the recurrence relation or the transition relation. Okay, so for example, here, if for every a we depend on a minus 1 and b minus weight. Simple thing. Now coming to base case will be very simple, similar to what we discussed in recursion. ठीक है, रिकर्शन में व्हाट आई टोल्ड कि बेस केस ऐसे स्टेट होना चाहिए, लाइक वेर you don't need further calculations. Okay, like base case should be such where you don't need further calculations. ठीक है, you already know the answer for that. Okay, DP में भी it's similar to that. For example, knapsack में we know the answer for DP 0 and 0. ये क्या सिग्निफाई करते हैं, दैट देयर इज नो आइटम, देयर इज नो वेट. ओके, तो वैल्यू भी जीरो होगा. व्हेन देयर इज नथिंग, वैल्यू विल आल्सो बी जीरो. फिबोनाची में बेस केस क्या होगा, लाइक द फर्स्ट एंड द सेकंड टर्म, we already know the first term is 1, the second term is also 1. Okay, so base case will be that case where we already know the answer. ठीक है. Now coming to the top down and bottom up. Okay, Diptiman had a doubt. Okay, so top down, what, so top down is generally easier. Okay, to visualize. This reason is very simple because it's very similar to recursion. Okay. So अभी तक हम लोग जो किए like from whatever I told, it's top down visualization. Okay. Now coming to how you can, I would say, convert the top down into bottom up. Okay. So this people can skip. This is not really necessary. In the interviews you can talk about top down and you can like clear those. Okay. So this is a bit of advanced. So like let's say how do you convert top down into bottom up. Okay. So let's say you have a recurrence relation. Let's take the example of knapsack only. Diptiman, this is more for you since you asked this question. Okay, so first of all, don't directly jump into bottom up unless you are a expert kind of a person. Okay, so first make the top, I would say top down approach. So let's take the example of knapsack. So f function of a and b calls the function of f a minus 1 b minus weight, and it also calls f a minus 1 and b. Okay, so the difference between top down and bottom up is that you should know how to run the for loops. Okay, so the difference here is that you should know how to run the for loops and the order of the states which need to be calculated first. टॉप अप में ये सब ध्यान रखने का ज़रूरत नहीं है. यू कैन सिंपली स्टार्ट द रिकर्शन, इट विल टेक केयर ऑफ इट सेल्फ by the recurrence relation. Okay, so when you start with a b, it will automatically call a minus 1 b minus 1, it will automatically call a minus 1 and b. Okay, but when you are doing bottom up, you should be very like you should know how to run the for loops because there is no recursion there. So if you observe here very carefully, a comma b depends on a minus 1 and b minus weight and a minus 1 and b. Okay, so a minus 1 should be calculated before a. Okay, similarly b minus weight should be calculated before b. Diptiman, just tell if this is understandable or not. Okay,
Yeah, yeah.
so like first see the order of the things which are dependent, like what means first identify the dependencies. Okay, like here you see that a minus 1 is dependent on a, sorry, a is dependent on a minus 1, b is dependent on b minus weight. So how should be the for loop? It should be from like for a from 1 to n, and b should be from 1 to like let's say the total weight. Okay, because b minus weight should be calculated before b. Okay, a minus 1 should be calculated before a. Okay, so first identify the dependencies, in that manner run the for loops. Okay, now let's say instead of b minus weight it dependent on b plus weight, let's say for example. Okay, so how the for loop would have run? It would have run in like for b from weight minus 1 to uh, weight to 1 in the reverse manner, because b plus weight should have been calculated before b, so we have to go in the decreasing manner. We have to calculate b plus weight before we calculate b. Okay, so this is the basic difference between like the top down and the bottom up approach. Like in top down you don't have to care about the order, you can simply start the recursion. So top down is very simple: identify the base case, identify the recurrence relation, simply run the recursion and keep on storing the values. It will take care of all the things automatically. Okay, but in bottom up, along with all the steps you did in top up, you also have to identify the order of the states in which they are calculated so that you are able to run the for loops. Okay, yeah, Diptiman, like any other question you have on bottom up?
So I had a question
Yeah,
on
go ahead.
bottom, top down. So can I ask
Yeah,
one
sure,
question?
sure.
Yeah, Anish, actually, the question is like, yeah, this part is okay, but I told you, na, ki like the direct jumping to this kind of solutions.
See, direct jumping will come with expertise. Okay, this is purely expertise. See, in rough work, what you can do is that uh, first you make, just a moment, Tarun. just a moment. Okay, so what you can do for direct thing is that first of all you make the base case. Simple thing, you make the recurrence relation. Okay, then you identify the order of the states in which they are calculated. Okay, if you can do this order of states in rough work or mentally, you can directly jump into bottom up. Okay, so this will come with practice. Okay, whether you know the order of the states, and I think if you do this in rough, I think it's pretty easy to like jump directly to bottom up from top down. Okay, cool. I think, yeah, Tarun, you can start.
So in this problem,
Hmm.
I have written the recursive part of this code,
Okay.
but I am not able to find the DP permanent top to down approach case. How can I apply DP in this question?
So what have you done in recursion?
So in regression, first I have calculated the sum of the whole array.
Okay.
Then it divided by two. If it is odd, then return false.
Okay.
And then I have made the recursive part for the half of the array, half of the sum.
Okay.
Like if it is equal, then it will be partition equals partition will be equal.
Okay. So this recursion thing is running.
Yes, sir.
So you are getting a TLE, right?
Yes, sir. Yes, sir.
Okay. So yeah, this is a very classic example which Tarun pointed out. Keep on presenting. Keep on presenting the question. Okay. So first identify what are the states you need to store so that you don't have to calculate the overlapping subproblems again and again. Okay. So this is a very classic example. First, here in the call itself, try to identify what will be the states of the DP. So you have written the recursion, so that means you have already made the recurrence relation. So your second part is done. The transition state, you have already done it. Here the only question remains that what states you need to store. So identifying the state is the thing that has remained. So what
Yes.
states do you need to store?
So I am not able to draw the recursive tree of this question. Like what should I store? That what could be the answers that DP should avoid? But like why should I use DP in that?
Because otherwise, let's say, let's explain this question. Okay, so let me present.
Should I stop sharing?
Yeah. Also, one more thing, if you go to the constraints part before you so here you see that number of lengths is 200. Okay, so this shouldn't be a case like what I'm trying to say is that like you should not look at the constraints for deciding how many number of states you need, but when you are a beginner, okay, so you can use the constraints as well to decide that how many states do you generally need. So here it will be 2 or 3 states, so it will be n square or n cube. So that's a hint you will get by seeing the constraint, but I think that you should not see when you are an expert or when you have experience. The reason behind that, in the interviews you will not get the constraints. Okay.
Okay, sir.
Okay, so question says that you need to find a subset with sum n by 2, right? Or let's say total sum by 2. This is the problem we need to solve, right? We need to find a subset with sum, let's say sum by 2, where this is the total sum of the array, right? Are yes or no something? Tarun has gone off after telling the question.
Yes, sir.
Okay, so let's say what are the states I need to store. Tell, try to put pressure on your brain. What are the states that is necessary? So think in like this manner, that if I control these variables, can I say that whether a sub array or a subset with sum by 2 is possible or not? Okay, so what are the variables you need to control? One is the number of items you have considered till now, and the sum of the current subset. Okay, so let's say the recursion tree will be something like this, that I have considered, let's say, I number of elements and my current sum is c sum. Okay, so if I have to make a subset using the first I elements and the sum of the subset has to be c sum, so there are two options. So I take the ith element or I don't take the ith element. Okay, so when I don't take the ith element, so this is my state, like previous state. When I take the ith element, it will be I minus 1 c sum minus array I. Okay, so this is the recurrence relation. Okay, so just present once and show that what was your recurrence relation, or
Okay, sir.
what are you doing it here? Like, so you are adding the nums j to sum, and if its value you return true, if it is greater than value return false. Go scroll down. uh, Yep. So you have done the means the recurrence thing, right? So
Yes,
once
sir.
you have added it, once you have not added it, okay. So the only thing you need to do here is that you need to store the value of the functions every time you are calculating. So in line number 17, whenever you are getting the value of res1, okay, you need to store that value of res1, and whenever you are getting the value of res2 in 20, you need to store that value again. Okay, so next time when you are calculating the answer for let's say sum, okay, you don't have to calculate it again and again. तो तुम्हारे यहाँ पे टी एल इसलिए आ रहा है क्योंकि तुम एक सम के लिए बार बार वो कैलकुलेट करते जा रहे हो, ठीक है? तो इफ़ यू स्टोर द वैल्यू ऑफ रेस वन एंड रेस टू इन अ ग्लोबल वेरिएबल, एंड उसको पहले ही चेक कर लो कि ये सम के लिए मेरा आंसर रेडी है कि नहीं, तो फॉर एवरी सम यू विल बी कैलकुलेटिंग ओनली वंस, तो तुम्हारा टाइम कैपेसिटी बहुत कम हो जाएगा, ठीक है?
Sir, like we use DP basically. I think when we have repetition.
हाँ, तो यहाँ पे रिपीटेशंस है ना, लाइक
Sir,
लेट्स, हाँ बताओ.
but how can we do? I can't draw its recursive tree. Like I check from recursive tree, and I am able
तो
to draw.
रिकर्सिव ट्री मैंने ड्रॉ कर दिया ना, आई और सी सम दे के. यू हैव ऑल्सो डन इट योर सेल्फ, तो मतलब तुम लाइक यू हैव डन इट, ठीक है? तो जस्ट अ मोमेंट, लेट मी प्रेजेंट इट अगेन. तो तुमने क्या किया है? सो लेट्स टेक योर सोल्यूशन ओनली टू एक्सप्लेन. सो यू हैव डन कि में लेट्स से यू हैव टेकन द वेरिएबल नेम एज वैल, राइट, और सम. Okay, so
Yes.
you are telling कि मैं sum, like I would add nums I to the sum and I will calculate that whether this sum is possible or not. Okay, then I would like send a simple sum and again check that whether this is possible or not, right? So these are
Yes.
the two states. So simple recursion tree है, I sum, and every time when you are sending it to the recursion you are incrementing I by 1, right?
Yes.
So I and sum will depend on I minus 1, sum minus nums I, and it will depend on the second state I minus 1, sum. सिंपल थिंग है, लाइक दो ही केसेस है ना, लाइक एवरी टाइम यूर इंक्रीमेंटेड आई प्लस वन, तो आई विल डिपेंड ऑन आई माइनस वन, क्योंकि आई माइनस वन इंक्रीमेंट होकर आई बन जाएगा नेक्स्ट इटरेशन में. And since there are two cases where you are adding num psi once and you are not adding in the second case, so एक केस में sum minus num psi पे डिपेंड होगा, एक केस में sum पे डिपेंड होगा. So this is the recursion tree.
So can we take an example?
तो मेरे को ये बताओ, तुम ये बिना sum से कैसे, like how did you write the solution, like what was your approach while writing the solution? Did you do it on your own or like you took help from something else?
No sir, by own myself sir.
तो उसमें क्या thought process था?
So like so thought process तो यही था सर, जैसे हाफ कैलकुलेट कर लिया मैंने सम, देन उसके बाद सर
नहीं, रिकरेंस रिलेशन का मेरे को थॉट प्रोसेस बताओ.
सर रिकर्सिव का मेरा थॉट प्रोसेस ये था कि सर अगर पहले मैंने एक एरे को सॉर्ट कर दिया अपने को, जो बेसिक मेरे को एरे मिली हुई है सर, देन उसके बाद मैंने सॉर्ट करने के बाद सर एरे के मतलब हर एक एलिमेंट के पास मेरे पास दो ऑप्शन है, या तो मैं उसको ऐड करूं या नहीं
हाँ,
करूं.
तो मैं भी तो वही बोल रहा हूँ ना, दैट इज द रिकरेंस रिलेशन. वही एग्जैक्ट जो तुमने बोला, वही एग्जैक्ट रिकरेंस रिलेशन है. फॉर एवरी आई एंड सम यू हैव टू ऑप्शंस, आइदर आई विल ऐड और आई विल नॉट ऐड.
बट सर मैं इसको एग्जांपल लेके करना चाह रहा हूं, तो एग्जांपल लेके मैं इसका रिकर्सिव ट्री बनाने में बड़ी दिक्कत आ रही है. मैं मतलब ये तो समझ गया, मैं अप्रोच तुम समझ
तो
पा रहा
लेट्स
हूं,
से
पर मैं
लेट्स से देयर इज एन एरे 1 5 11, लेट्स से 1 5 एंड 6. ओके, ठीक है. तो सम बाई 2 क्या होगा, 6 होगा, राइट? तो
yes
इनिशियली वी नीड टू कैलकुलेट कि मेरे पास 3, 6 ये स्टेट का आंसर ट्रू होगा कि नहीं होगा, राइट?
yes सर.
ठीक है. सो 3, 6 विल डिपेंड ऑन, वी आर टेकिंग फ्रॉम द फर्स्ट एलिमेंट 2, 5. ओके, एंड इट विल डिपेंड ऑन 2, 6. ठीक है. 2, 5 will depend on 1, 0 and it will depend on 1, 5. ठीक है. It will depend on 1, and it will depend on 1, 6. तो बेस केस यहाँ पे क्या होगा, अगर सम 0 है तो वी हैव ऑलरेडी अचीव्ड इट, लाइक दिस विल बी ट्रू. सो व्हेन सम इज इक्वल 0, द आंसर विल ऑलवेज बी ट्रू. सिंपल रीज़न है, क्योंकि वी कैन ऑलवेज हैव अ एम्प्टी सबसेट जिसका सम 0 होगा. ठीक है.
नहीं सर, इसके अंदर फिर जो हमारा रिपीटेटिव पार्ट है वो नहीं आया सर.
कौन सा रिपीटेटिव पार्ट?
मतलब डीपी लगाने के लिए जो मतलब डीपी हम जिसमें लगाते
रिपीटेटिव
हैं
हो रहा है
सर.
ना. लेट्स से अभी लेट्स से इफ वी अराइव एट अ सर्टेन स्टेट वेयर देयर इज अगेन 1, 0. ठीक है. लेट्स सपोज इस केस में नहीं होगा, बट लेट्स सपोज देयर इज अ केस जहाँ पे फिर से 1, 0 आ गया, तो तुम 2 बार कैलकुलेट करोगे क्या? तो यू नीड टू स्टोर द आंसर ऑफ DP 1 and 0 so that you don't have to calculate it again. ठीक है. सो लेट्स से इंस्टेड ऑफ 1 5 1 you have 1. ओके, 1 5 6 you have 1 5 1. ओके, तो इस केस में 1, 1 विल लीड टू 1, 0. ठीक है. तो तुम 1, 0 को 2 बार कैलकुलेट करोगे. सो
सर इसमें तो आंसर ही नहीं आएगा ना.
आंसर नहीं आएगा, बट लेट्स से यू हैव स्टार्टेड द रिकर्शन. मैं तुमको ये समझाने की कोशिश कर रहा हूँ कि ओवरलैपिंग सब प्रॉब्लम्स हो सकता है. इस केस में ये है कि नहीं आएगा, सही बात है, नहीं आएगा, लेकिन ओवरलैपिंग सब प्रॉब्लम्स आ सकते हैं ना. लेट्स टेक एन एग्जांपल. ऐसे लेते हैं 1 1 1 1. ठीक है. सो हियर वी नीड टू कैलकुलेट 4, 2, राइट? ये ओरिजिनल स्टेट है. 4, 2 से क्या आएगा, 3, 1. और
Yes,
क्या आ
sir.
सकता है, 3, 2, 2, 0, 2, 1. लो आ गया रिपीटेटिव सब प्रॉब्लम. लो आ गया. आप बताओ 2, 1 को 2 बार कैलकुलेट करोगे क्या, अगर स्टोर नहीं करोगे तो?
ओके सर.
तो हर समय लाइक यू हैव टू स्टोर DP I एंड सम. आई का मतलब है कितना एलिमेंट्स तुमने कंसिडर किया है, सम का मतलब सम ऑफ द करंट सबसेट, ठीक है।
मतलब सर इसमें 2D डीपी बनेगा ना?
हाँ 2D DP बनेगा, ठीक है। So
ओके
if we have to summarize, it's very simple. DP is recursion with memorization, okay. Like in recursion you don't memorize the answers, sorry, in recursion you don't memorize the answers. In DP you do the exact same thing and you memorize so that you don't have to calculate the same states again and again, okay. So here also you need to find out the base case, you need to find out the recurrence relation. So in recurrence relation, you first need to identify the states you need to control or identifying the states. Then you need to find the relation between the states as we discussed. And the last part is time and space complexity. So time and space complexity calculate करने का सबसे आसान तरीका है number of states into transition time for every state, okay. So let's say जो अभी सम था लाइक व्हाट दैट सबसेट सम, सो नंबर ऑफ स्टेट्स इज 2, ओके, लाइक इट्स अ 2D DP, राइट. तो लाइक इट वाज आई एंड सम, सो आई कैन रेंज फ्रॉम 1 to n, okay. So the first state will be of n, the second state is sum, so sum can range from 1 to sum of the array, right. So it will be n into sum of the array. Now let's say for every state what we are doing, for every state we are using constant space, like we are adding it once, like we are adding the current element or we are not adding the current element, okay. So every state is taking a constant time, so it will be 1 for this example, okay. So it will be n into sum of array in this example. So if I generalize or if I talk about how you should calculate the time complexity of DP, for every state identify what will be the range, take the product of that, and then see that for every state what you are doing. Let's say for every state if you are running a for loop, okay, which is of the order O of n, so it will be product of the range of the states into n, okay. Like that you calculate the time. Space will be product, only this product, okay, like product of the range of the states, that will be the space, because you will be using an array of that length. For example, in this subset sum, so the first index will vary from n 1 to n, the second index will vary from 1 to sum of the array, okay. So you will be using an array of dp n sum of the array, okay. This will be the length of the dp array. So transition part is very simple. Let's say for every state, so let's say a function x comma y, to calculate the value of function x comma y, I am running a for loop from, like, let's say I 1 to 100, okay. So this is the transition time, so it will be range of x into range of y into 100, because for every state we are using 100 time, okay. So now let's say instead of 100 this can go up to, let's say, n, okay. So instead of 100 we will multiply it by n, okay. So simple thing, layman term explanation, कितना स्टेट बन रहा है वो इनटू एक स्टेट के लिए कितना टाइम लग रहा है वो टोटल टाइम दे देगा, ठीक है. So this is the how you derive the time and space complexities of DP. Any other questions anyone has on how you should approach the DP problems?